What's up guys, my name is Cornelius Robinson and welcome to Overshoot, where I show you how to use Flux, the future of hardware development. In the last video, I briefly covered expressions and how to use them. Today, I want to cover a couple more that should make your life a bit easier, so let's get into it. When quickly simulating a circuit, you will likely run into uncommon part values. For example, if I want to find the value of this resistor, we need to find the voltage drop across the resistor, which is 12 volts minus the forward voltage of the LED, which is 1.7 times 2. That equals 8.6 volts. Then we can use Ohm's law to calculate the resistance. So 8.6 volts divided by 20 milliamps equals 430 ohms. The only problem with 430 ohms is it's not always a common resistor value, but we can change that with an expression. Before I get into that though, let me explain common values for context. I'm not going to get into too much detail here, but IEC 60063 is an international standard that provides a series of preferred values for resistors and capacitors. Depending on how precise you need your components, you get anything from the E3 series with only a few values to E96 if you want to get that precise. The values you see here are for each decade. For example, 27 can be 2.7 ohms, 270, 2.7k ohms, and so on. For now, I'm just going to focus on series E6 and E24. As you might have guessed, each category also corresponds to tolerance. Now that we know that, let's head back to Flux and convert our resistor into an E6 value. The expression needed is simply equals 2E6 with the value in parentheses. As you can see down here, the closest real part value is 470 ohms. That correlates to the list of values in E6. Now, if we change that to E24, for example, it comes out to the original value of 430 ohms because it's a standard resistor value in the E24 series. One other thing I want to bring up is expression nesting. This is probably familiar to you if you've done any amount of coding. In the last video, we used an expression to calculate the LED ballast resistor for us. Well, this works with the 2E expression as well. We don't have to calculate anything in reality. Just place the LED ballast expression inside of the 2E parentheses. We just need the current and the voltage drop, which Flux will also calculate for us. And there we go. We get the same value as before. This is a pretty simple example, but you can see how this could be used for more complex circuit calculations. Alright guys, that's it for this video, but I hope that's been helpful. If so, give it a like and make sure you subscribe. Until then, I'll see you in the next one.